Hi everyone, welcome back to the AI Academy. Today, we are diving into our Business Analytics for Management Decision course. Our topic for today's lecture is all about how businesses use data to make decisions. We will cover things like how to plan out the data strategy, understanding different variables, data visualization, its architecture, understanding measurement scales, and the overall process of using data to make decisions. Let us start today's lecture with data strategy definition. A data strategy is a plan that organizations create to manage and utilize their data effectively. It helps them understand what data they have, where it's coming from, how it should be stored, and how it can be used to benefit the organization. Next is variables. They are like placeholders or containers that can store different values or pieces of information. For example, in a spreadsheet, we might have a variable called age, where you can store different age values for different people. Data, it refers to collected facts and figures. It's like raw materials that have not been processed or analyzed yet. For instance, the heights and weights of a group of people would be considered data. Database, it is a collection of files that are used to store data in an organized way. It's like a big filing cabinet where you can store and retrieve different types of data. It makes it easier to manage and access large amounts of information. Information, it is what we get when we analyze or process data in a meaningful way. If we take the heights and weights of a group of people and calculate their average body mass index, the resulting BMI values would be considered information. It is data that has been organized, processed, and given context or meaning. In summary, a data strategy helps organizations plan how to manage their data effectively. This data is stored in databases. By analyzing the data, organizations can derive useful information that can help them make better decisions or gain insights. Let's talk about variables for business analytics in easy terms. Variables are characteristics or attributes that can take on different values. There are two main types of variables. Categorical or qualitative variables. These variables represent different categories or groups. For example, gender, marital status, that is single, married, divorced, or product color like red, blue, green. Quantitative variables. These variables represent numerical values or measurements. For example, age like 25, 42, 67, height like 165 centimeters, 178 centimeters, 192 centimeters, or sales figures like 1,000, 5,000, 10,000. Dependent and independent variables. These terms describe the relationship between variables in a study or analysis. Dependent variable. This is the variable that is being studied or measured. It is the outcome or effect that depends on or is influenced by other variables. Independent variable. This is the variable that is being manipulated or changed to observe its effect on the dependent variable. Endogenous and exogenous variables. Endogenous variables. These are variables that are determined or influenced by other variables within the system or model being analyzed. Exogenous variables. These are variables that are determined or influenced by factors outside the system or model being analyzed. Explained and explanatory variables. Explained variable. This is the variable that is being explained or predicted by the other variables in the analysis. Explanatory variable. This is the variable that helps explain or predict the value of the explained variable. Effect and cause variables. Effect variable. This is the variable that represents the outcome or result of a change in another variable. Cause variable. This is the variable that is thought to influence or cause a change in another variable. Controlled and control variables. Controlled variable. This is a variable that is kept constant or fixed in an experiment or analysis to isolate the effect of other variables. Control variable. This is a variable that is included in an analysis to account for its potential influence on the relationship between other variables. Outcome and covariate variables. Outcome variable. This is the variable that represents the main outcome or result being studied in an analysis. Covariate variable. this is a variable that is included in an analysis to account for its potential influence on the relationship between other variables. Regressand and regressor variables. Regressand variable, this is the variable that is being predicted or explained in a regression analysis. Regressor variable, this is the variable that is used to predict or explain the regressand variable in a regression analysis. Predictand and predictor variables. Predictand variable, this is the variable that is being predicted or estimated in an analysis. Predictor variable, this is the variable that is used to predict or estimate the value of the predictand variable. Response and stimulus variables. Response variable, this is the variable that represents the outcome or response being measured in an experiment or analysis. Stimulus variable, this is the variable that represents the input or factor being manipulated or changed to observe its effect on the response variable. These terms are used to describe the relationships between variables in various types of analyses and studies, particularly in fields like statistics, economics, and business analytics. Let's dive deep into understanding data architecture. Data architecture refers to the overall structure and organization of data within an organization or system. It defines how data is collected, stored, processed, and used. Well-designed data architecture ensures that data is accessible, secure, and efficiently managed. Big data and small data. Big data, this refers to extremely large and complex datasets that are difficult to process and analyze using traditional methods. It is characterized by its volume, velocity, and variety. Small data, this refers to smaller, more manageable datasets that can be easily processed and analyzed using traditional methods. Primary and secondary data. Primary data, this is data that is collected directly from the source for a specific purpose. For example, conducting surveys, experiments, or observations. Secondary data, this is data that has been collected by someone else for a different purpose, but can be reused or analyzed further. For example, census data, market research reports, or social media data. Quantitative and qualitative data. Quantitative data, this is data that can be measured and expressed numerically. For example, sales figures, temperatures, or heights. Qualitative data, this is data that describes qualities or characteristics and cannot be easily measured numerically. For example, opinions, emotions, or preferences. Experimental and non-experimental data. Experimental data, this is data collected through controlled experiments or studies, where variables are manipulated and their effects are observed. Non-experimental data, this is data collected through observational studies or surveys, where variables are not manipulated, and events are observed as they naturally occur. Structured and unstructured data. Structured data, this is data that is organized and stored in a predefined format, such as databases or spreadsheets, making it easy to search, analyze, and process. Unstructured data, this is data that does not have a predefined structure or format, such as text documents, emails, videos, or social media posts, making it more challenging to analyze and process. Internal and external data. Internal data, this is data generated and collected within an organization, such as sales records, employee data, or production logs. External data, this is data collected from sources outside the organization, such as market research, social media data, or public databases. Traditional and new data. Traditional data, this refers to data collected and stored using traditional methods, such as surveys, census data, or financial records. New data, this refers to data generated from modern sources, such as social media, mobile devices, sensors, or online transactions. Free and purchased data. Free data, this is data that is available for public use or can be accessed without any monetary cost, such as open government data or freely available online resources. Purchased data, this is data that must be acquired by paying a fee or subscribing to a service, such as market research reports, industry databases, or proprietary data sources. Historical data, it refers to data collected and stored over a long period of time, providing a historical record or timeline of events, trends, or patterns. This data can be useful for analyzing past performance, identifying trends, or making predictions based on historical patterns. Data for business analytics. Examples of using data in business. Annual reports. These are like report cards for the company, showing how well we did financially over the past year. They are packed with data on things like sales, expenses, and profits. With this information, we can see what areas are doing well and what might need some improvement. Then there are accounting audits. These are like double-checking the math homework, but for the business's finances. An auditor goes through all our financial records with a fine-tooth comb to make sure everything adds up and is on the up and up. Speaking of finances, financial profitability analysis is all about using data to figure out how profitable the business is and how we can make it even more profitable. But it's not just about the money. We also want to keep an eye on economic trends, which is like watching the weather forecast for the business world. This data helps you anticipate any storms or sunny skies ahead so you can plan accordingly. Marketing research is another big one. It is like asking the customers what they want and using that data to give it to them. We can find out what products or services they are interested in, what prices they are willing to pay, and how to reach them most effectively. Operations management performance is all about using data to make sure the business is running like a well-oiled machine. We can track things like production times, inventory levels, and delivery schedules to identify any bottlenecks or inefficiencies. Last but not least, human resource measurements help us to keep tabs on the most valuable asset, the employees. We can use data to monitor things like turnover rates, training effectiveness, and employee satisfaction levels. After all, happy employees make for a happy business. Let's discuss some more about data for business analytics. When it comes to analyzing data in a business, we need to look at specific things that help us understand how well the business is performing. These things are called metrics. Metrics are like rulers or scales that we use to measure different aspects of a business. Now, these metrics don't give us actual numbers or values on their own. We need something called measures to get those numerical values. They are the numbers or values that we get when we apply the metrics to different parts of the business. For example, let's say we want to know how many orders were delivered on time. On time or not on time would be our metric, and the measure would be the actual number or percentage of orders that were delivered on time. Some metrics involve counting specific things, like the number of orders delivered on time or the proportion of orders that were on time. These are called discrete metrics because they deal with whole, separate units or categories. Other metrics are measured on a continuum, which means they can take on any value within a range. These are called continuous metrics. For instance, the delivery time for each order is a continuous metric because it can be any number of minutes, hours, or days, not just a whole number. Some examples of continuous metrics are: delivery time for each order, weight of each package, purchase price of each item. These metrics can take on any value, not just whole numbers or categories. So, in summary, metrics are like rulers or scales that we use to measure different aspects of a business. Measures are the actual numerical values we get when we apply those metrics. Some metrics involve counting discrete things, while others measure continuous values that can fall anywhere on a range. By keeping track of these metrics and measures, businesses can get a better understanding of their performance and make informed decisions to improve or maintain their operations. Let us take example of data and how it can be used. Let's discuss on the type of data based on measurement scale. Categorical or nominal data. Categorical or nominal data refers to information that is divided into distinct groups or categories based on a specific characteristic. These categories do not have a numerical or quantitative relationship with one another. In other words, they are not ordered or ranked in any way. Here are some key points about categorical data. Data is placed into categories. It is sorted into different groups or categories according to a particular characteristic or attribute. For example, customers can be categorized based on their location, employees can be categorized based on their job classification, or individuals can be categorized based on their gender. Categories have no quantitative relationship. The categories in categorical data have no numerical or mathematical relationship with one another. They are simply different labels or names used to identify distinct groups. For instance, the categories America, Europe, and Asia for customer locations do not have any numerical relationship or order between them. Some of the examples are: customer's location, America, Europe, Asia are different area. Employee classification, manager, supervisor, associate that is having different job roles. Employee classification, male, female that is having different genders. Employee classification, adult, child that is having different age groups. In these examples, the data is divided into distinct categories based on a specific characteristic, such as location, job role, gender, or age group. These categories do not have any numerical or quantitative relationship with one another. They are simply different labels or names used to identify and group the data. Ordinal data. It is a type of data that involves a ranking or ordering of items according to a specific relationship or criteria. Unlike numerical data, it does not have fixed units of measurement, but rather, it represents a relative position or order among the items being measured. Here are some key points are: ranked or ordered data. It is arranged in a specific order or sequence based on a particular characteristic or attribute. For example, college football rankings, management school rankings, or survey responses are ordered from highest to lowest, best to worst, or most favorable to least favorable. No fixed units of measurement. The difference between the ranks or positions in ordinal data cannot be precisely quantified or measured using fixed units. The rankings or positions only indicate a relative order or relationship among the items, but not the exact magnitude or distance between them. Some of the examples are: college football rankings, Ravenshaw, Christ, Xavier that is ranked from higher to lower position. Management school rankings, VGSOM, UMA, IIMB, UMC, IML, XLRI that is ordered from top-ranked to lower-ranked schools. Survey responses, poor, average, good, very good, excellent that is ordered from least favorable to most favorable ratings. In these examples, the data is organized in a specific order or sequence, but the exact difference or distance between the ranks or positions is not defined or quantifiable. For instance, in the management school rankings, we know that IIMA is ranked higher than IIMB, but we cannot determine the precise difference or magnitude between their rankings. It is useful for comparing and ranking items based on a particular characteristic or attribute, but it does not provide information about the specific intervals or magnitudes between the ranks or positions. Interval data. It is a type of data where the values are ordered or ranked, and the difference between any two consecutive values is constant or equal. However, it does not have a true zero point, which means that ratios or proportions between the values are not meaningful. Here are some key points about interval data. Ordered data with constant differences. Interval data is ordered or ranked like ordinal data, but the difference between any two consecutive values is fixed or constant. For example, the difference between 10 degrees Celsius and 20 degrees Celsius is the same as the difference between 20 degrees Celsius and 30 degrees Celsius, which is 10 degrees. No true zero point. Interval data does not have a true zero point, which means that a value of 0 does not represent the absence of the measured quantity. For instance, 0 degrees Celsius does not mean the absence of temperature, it is simply a reference point on the Celsius scale. Ratios or proportions are not meaningful, because interval data lacks a true zero point. Ratios or proportions between the values are not meaningful or interpretable. For example, it is not meaningful to say that 40 degrees Celsius is twice as hot as 20 degrees Celsius because 0 degrees Celsius does not represent the absence of temperature. Some of the examples are: temperature readings, Celsius or Fahrenheit scales. Example, 10 degrees Celsius, 20 degrees Celsius, 30 degrees Celsius. SAT scores, range from 400 to 1600. Example, 1200, 1300, 1400. CAT scores, range from 0 to 300. Example, 80, 120, 160. In these examples, the differences between consecutive values are constant. Example, 10 degrees, 100 SAT points, 40 CAT points, but a score of 0 does not represent the absence of the measured quantity. Example, 0 degrees Celsius does not mean no temperature. A score of 0 on the SAT or CAT does not mean no ability. While it allows for meaningful comparisons of differences between values, it does not support meaningful ratios or proportions due to the lack of a true 0 point. Ratio data. It is a type of continuous data that has a true or natural 0 point, which means that a value of 0 represents the complete absence of the measured quantity. In ratio data, ratios or proportions between values are meaningful and interpretable. Here are some key points are: continuous values with a natural 0 point. It consists of continuous values that can take on any value within a range, including 0. A value of 0 in ratio data represents the complete absence of the measured quantity, such as no sales, no time elapsed, or no wait. Ratios are meaningful, because it has a true 0 point. Ratios or proportions between the values are meaningful and can be interpreted. For example, if one item weighs 10 grams and other weighs 20 grams, it is meaningful to say that the second item is twice as heavy as the first. Some of the examples are: monthly sales, the amount of money earned from sales. Example, $0, $5,000, $10,000. Delivery times, the time taken to deliver an item. Example, 0 minutes, 30 minutes, 2 hours. Weekly sales, the number of items sold in a week. Example, 0 items, 50 items, 200 items. Processing timings, the time taken to process a task. Example, 0 seconds, 5 seconds, 20 seconds. In these examples, a value of 0 represents the complete absence of the measured quantity, such as no sales, no time elapsed, or no items sold. Additionally, ratios between values are meaningful and interpretable. For instance, if a delivery took 10 minutes and another took 20 minutes, it is meaningful to say that the second delivery took twice as long as the first. It is the most robust and flexible type of data because it allows for all mathematical operations, including addition, subtraction, multiplication, and division, as well as the calculation of meaningful ratios and proportions. Let's discuss one of the important topic, data visualization. When we talk about data visualization, we are referring to the practice of representing data in a visual format, such as charts, graphs, maps, or other visual aids. The goal is to make it easier for people to understand and interpret the data and to identify patterns or trends that might not be immediately obvious from looking at raw numbers or text. Let's start with the first example: 1, 2, 25, 50, 500, Delhi, gender, 15K 5002, XYZ at gov.in. At first glance, this might just seem like a random collection of numbers, words, and characters. However, this is what we call data. It's raw, unprocessed information that doesn't really convey any meaningful insights on its own. Now, let's look at the second example: 100.0, 200.0, 250.0, 150.0, 220.0, 300.0, 310.0. Again, this is just a list of numbers, and without any context, it's difficult to understand what this data represents or what information it's trying to convey. This is where data visualization comes into play. By representing this data in a visual format, such as a line chart or a bar graph, we can start to see patterns emerge and gain insights from the information. For example, if we plotted these numbers on a line graph, we might see that they represent fluctuations in a particular metric over time, such as monthly sales figures or stock prices. The key distinction here is that data is raw, unprocessed information, while information is data that has been organized, processed, and presented in a way that makes it meaningful and actionable. It is a powerful tool for transforming raw data into information that can be easily understood and acted upon. In the world of business analytics, it is crucial for communicating complex insights and findings to stakeholders in a clear and compelling way. By presenting data in a visual format, decision-makers can quickly identify trends, outliers, and areas of opportunity or concern, and make more informed decisions based on the information at hand. So, while the examples we provided might seem like just a bunch of random numbers and characters, data visualization techniques can turn that raw data into meaningful information that can drive business growth and success. Let us conclude today's lectures by discussing on data analytics process. First up, you have got to get your master data in order. This is all the critical business information, customer records, product details. Having a solid master data management system ensures the core data is accurate, consistent, and easily accessible. But just having the data is not enough, we need to actually see and understand it. That's where data visualization comes in. This is like turning numbers and figures into graphs and charts that are easy to understand, kind of like making a colorful picture out of a dull list. Of course, for any of this to work, the data needs to be squeaky clean. Data quality makes sure the data is clean, complete, and up to date. Dirty or incomplete data can lead to wrong conclusions. The next step is integrating data from across different systems and sources into one unified view. This could be combining customer information from the website and the store. This process is called data integration. Next is data transformation. It is changing the format or structure of the data to make it easier to analyze. Setting up rules and guidelines for how the data should be handled and used, like making sure everyone follows the same rules. The responsibilities of data governance. Let's wrap up today's lesson by talking about data analysis process flows. Let's start with reporting. This is basically giving us the hard facts and key metrics about what's happening in the business. It is like performance scorecards or visual dashboards that shows all the numbers at a glance. Handy for quickly checking in on how things are doing. Next up is descriptive. This is like digging into the past to understand what happened. It is all about looking at statistics and historical data to describe what happened and why. It helps provide context around those top-line reporting numbers. Predictive analysis takes it a step further by using techniques like forecasting models to predict what could happen next based on current trends and patterns. This is really powerful for getting recommendations on what actions to take going forward. Prescriptive analysis goes even further by running simulations and what-if scenarios. It allows you to test out different potential decisions and see how various factors could impact outcomes before actually implementing anything. Basically a risk-free way to identify the best prescribed solution. Finally, machine learning is an advanced technique that uses artificial intelligence to automatically discover hidden insights and patterns in large, complex data sets that would be extremely difficult for a human to detect. So in essence, its reporting shows us what's going on, descriptive adds context, predictive gives you a glimpse into the future, prescriptive allows you to model different options, and machine learning reveals things we may have never picked up on otherwise. Having a handle on all these different analytical processes gives you a really comprehensive, multidimensional view for making smart decisions. In summary, this lecture covered the following topics such as how to plan the data strategy, understanding different variables, data visualization, its architecture, understanding measurement scales. Finally, we'll conclude with overall process of using data to make decisions. We hope that you have found this course informative. Please hit the like button and subscribe to our channel for more information on business analytics for management decision content. Your support is really important to us and it encourages us to make more educational stuff for you. In our next video, we will continue our discussion on different topics of business analytics. We will see in detail about the following topic: knowing decision models, its classification, structure, and we will see some real-life examples. Stay tuned for the next lecture, where we'll continue our journey through business analytics for management decision courses. Thank you for watching and see you again.